In this tutorial, we'll understand what logical replication is and why it's so popular. Then we'll check which are the steps to set up the replication, why we must make sure that the cluster is properly monitored, in what cases it's best to use logical replication, and finally, which are the current limitations and how we could overcome them. PostgreSQL includes a built-in, powerful and flexible feature called logical replication. It was officially released in PostgreSQL version 10 and it has been largely used since then. In many, if not most use cases, it can be considered a better alternative to physical replication in which we send bytes of data resulted from executing the SQL commands on the master server. In contrast, when using logical replication, we send the actual SQL commands. Physical data replication has some small disadvantages. First, the replica is forced to receive absolutely all the databases, tables, roles, table spaces, and so on from the original server. With physical replication, we get all or nothing. But what if we want to replicate only a single table? This is where logical replication comes into play. Here, we can choose only a subset of the tables that we want to replicate, and Postgres will replay the DML commands on the replica. Let's see shortly how it does so. First, Postgres has to decode logically the records from the WAL file and make SQL statements. Then, the SQL statements are streamed over the network to the standby server. Finally, the statements are applied to the tables in the standby server in the correct transactional order. In logical replication, we have two entities, a publisher and a subscriber. A publisher is a node that represents a certain group of tables, also called a publication. Then, to receive the changes from that particular group of tables, a subscriber can sign up by creating a subscription. Another point in favor of the logical replication is the amount of data that has to be replicated. Physical replication has to transfer every modification from the master server, even if this modification doesn't change the data itself. For example, if an index is created on a table, it's not the create index command that is sent to the standby, but instead all the modification involved in creating an index, which can be huge sometimes. This can create excessive load on the network and can become a bottleneck for a system that is under heavy load. Since in physical replication everything is transferred, we can't choose to simply run the same command on the replica. Same happens for the vacuum command. This is executed periodically and it removes the dead tuples from the tables and therefore it creates a lot of data changes which need to be transferred. Same happens for the cluster command that rearranges the rows. Although logical replication doesn't support DDL commands such as create index, we can execute it separately on the replica. We'll see later how to do this easily in practice. In this case, the amount of data sent over the network will be much smaller. Furthermore, physical data replication requires an identical configuration for the servers that are in sync. The data has to be placed at the same location on the file system. This means that we can't use this type of replication to make migrations since we can't use different versions of PostgreSQL for the master and the standby. In contrast, in logical replication, as the transfer happens at the level of SQL and not the low level of bytes, we can configure the subscriber to have different data structures. As long as the SQL commands can be executed, it will work. Therefore, we can use logical replication to perform migrations and upgrades. What's more, the data structure on the tables doesn't need to be the same. For example, we can execute an SQL command such as insert into table 1 values 1 and 2 on the master. It's not a problem when the table has more columns on the standby than A and B. The SQL statement is correct, therefore it can be executed. The extra columns will get their default values. As mentioned, when talking about logical replication, there is no master and standby. there is the publisher and the subscriber. This allows to have much more control, and we can set up multiple architectures based on our needs. For instance, we could have one subscriber that is pulling data from two machines or more, and it aggregates the data. Or we can have one publisher who is broadcasting data to more than one subscriber, each with its own set of tables. Logical replication works on the level of individual tables or subsets of tables. Also, it is possible to set up the replication for all the tables in a database. In this case, any new table will be automatically replicated. However, logical replication doesn't affect other schema objects such as sequences, indexes, or views.